Hey guys, welcome back to class. This is Professor B, and today we are going to do systems of linear equations, and we are going to do the substitution method today. Okay, so I've got my mild, medium, and spicy, and let's see where we go. All right, so the first one we're looking at is y equals 4x minus 9 and y equals x minus 3. And what we're basically looking at is you've got two lines and you are looking at where are they going to cross. Okay, so we're looking for that intersection point, if it has one. Okay, so for the substitution method, what you're doing is you are replacing one letter with the equation, essentially. All right, for instance, both of these equations equal y. So you could replace this y, oops, you could replace this y with this equation because they both equal the same thing, right? They both equal y. So that's exactly what we're going to do here. We are going to set 4x minus 9, because that's our y value, equal to x minus 3. Okay? After you do that, you'll solve for whatever the remaining variable is. So sometimes you'll be able to solve for the y, sometimes it'll be the x, okay? It doesn't matter which one you solve for first, but we're going to solve for the x here because that's all we have left. So I will subtract x from both sides. So now I have 3x minus 9 equals negative 3. Adding 9 to both sides. So I get 3x equals 6. Divide both sides by 3, and my x equals 2. So that's my x value. But remember, if you are graphing these things, there's going to be an x and a y coordinate because it's a point. So we have our x value, it's a 2, but now we need to find our y value. In order to do that, we are going to take the x that we have found and we're going to plug it in to one of our equations. It does not matter which equation you plug it into. Okay, I'm going to plug it into this bottom one just because that x is already by itself, less work to do. So I'm going to say y equals, and my x value is 2 minus 3. So I have 2 minus 3, so y equals negative 1. And that is my point. Okay, so it's as easy as that. We want to replace one letter with the equation, solve for the remaining variable, then use that value to plug into one of the original equations and solve for that remaining variable. Okay, but if you're not sure about your answer, if you are just, I want to make sure, there's a check to this. Okay, so what you're doing is you're going to take this point that you found and we're going to check it to see if it's right. All right, we are going to see if it is an actual solution to this system. And the way you do that is you're going to plug your y value in, you're going to plug your x value in, and see if they come out to be the same value. Okay, the only trick to this is you have to do it with both equations. You can't stop at one. Okay, so I have a y value. So I'm going to do negative 1, that's my y value, equals 4 times my x value, which is 2, minus 9. Okay, and I'm also going to go ahead and plug it into the other one. That also equals y value, which is negative 1, equals my x value, which is 2, minus 3. Okay, and then all you're going to do is evaluate those. Okay, so I get negative 1 equals, this is 4 times 2, which is 8, minus 9, which is negative 1. Negative 1 equals negative 1, so I know I got that one right. But we have to check the other one as well. So when we check the other one, we get negative 1 equals, and then 2 minus 3 is also negative 1. So it worked in both instances. So that means that 2, negative 1 is a solution. Okay, let's take a look at a slightly spicier one. Let's look at our medium one. Okay, we have 4x plus 2y equals 10, and we have x minus y equals 13. Okay, so when you are doing the substitution method, it was probably easier for you if you look for a variable that is already mostly by itself. If you looked in our mild example, we already had the y's completely by themselves. They were already solved for. It was great. But you're going to come across problems that look like this where it's not always an easy thing to look for. All right, the x isn't completely by itself, the y isn't completely by itself, but we can make it that way. Okay, so what I like to do is I like to look for variables that already have a leading coefficient of 1. I have both of these down here, so I'm going to go ahead and solve for the x because it's also already positive. Again, it really doesn't matter. If you were to solve one of these top ones for the x or the y, you can still get to the same answer. Okay, so I am going to take x minus y equals 13, and I am going to add y to both sides. Okay, negative y plus y is 0, so I'm left with x, which is what I want, and then I have 13 plus y. Remember, we can't combine those because they're not big terms. After we have done that, again, the next part is we are going to substitute, instead of an x in our first equation, we're going to substitute the 13 plus y. We can't plug this equation back into the one we solved for because then we're just going to end in an endless loop, and we don't want to do that. All right. So if I have my 4 times my x value, and again, instead of an x, we're going to do the 13 plus y because they equal the same thing. That's why they have the equal sign. 13 plus y plus 2y equals 10. So now this entire equation is written in terms of y, so I will solve for my y. So I'm going to distribute my 4 times 13 is 52. 4 times y is a positive 4y plus 2y equals 10. I'm going to clean up a little bit more, so I am going to combine like terms right here. I've got the 4y plus 2y. So I have 52 plus 6y equals 10. And I'm going to solve for the y. So I will subtract 52 from both sides. And I get 6y equals negative 42. And then I will divide both sides by 6. So my y equals negative 7. So this time I found the y value first. Okay, perfectly acceptable. So I'm just going to leave a space there, and then I'm going to put negative 7. All right. Then what I'm going to do is I'm going to take the value that I have found for y, and I'm going to plug it back into one of my equations. It does not matter which one, and solve for the x. Again, I think I'm going to go with this one down here just because there's not a whole lot of things that I have to multiply against. So I have my x value minus my y, which in this case is a negative 7, equals 13. So minus a negative, that means x plus 7 equals 13. I'm going to subtract 7 from both sides. And my x equals 6. Okay. So once again, what I'm going to do, just to make sure I got everything correct, is I'm going to move this guy over here a little bit more. And I'm going to check my answer because I want to make sure that I got it correct. So I'm going to plug my 6, negative 7 coordinate in for both my x and my y. So I have 4 times my x value, which is 6, plus 2 times my y value, which is negative 7, equals 10. And then to plug it into my other one, I have my x value, which is 6, minus my y value, which is negative 7, and that equals 13. Okay, so just checking, I'm going to have 4 times 6 is 24, 2 times negative 7 is negative 14, 24 minus 14 is 10, and that equals 10. So I'm halfway there. And then for the bottom one, I have 6 plus 7, that equals 13, and which equals 13. That is also a true statement. So since they both worked out, I know that this is an actual answer, a solution to my system, and I'm done. Okay? So in a perfect world, to use substitution, we are going to look for those variables that are by themselves. Well, in our spicy example, we see what happens when we can't always do that. Okay, so take a look at this guy. We have a 5x plus 8y equals negative 17, and we have 2x minus 7y also equals negative 17. So we are going to go through this one and show you what it looks like when you can't always look for a variable by itself. As you see, both of these have coefficients that are not 1. Okay? So again, doesn't matter which one you pick for. I'm just going to go ahead and pick the bottom one. Doesn't really matter why, or if you pick the top one. So I'm going to go ahead, I'm going to pick 2x minus 7y equals negative 17. Okay, and I'm just going to solve for x. Call it creature of habit. Okay. So first thing I'm going to do is I'm going to add 7y to both sides. So I end up with 2x equals negative 17 plus 7y. And then what I have to do is I have to divide both of these by a 2. So I'm going to end up with kind of a messy fraction. I have x equals negative 17 plus 7y divided by 2. Okay, so that's kind of a messy fraction. Don't worry though, because when we start cleaning stuff up, it very well could come out to be a whole number. All right, it doesn't have to, but most of the time it probably will. All right, so we are going to take this x that we have solved for, and we're going to plug it into our first equation now. Remember, the second equation is the one we used to solve for x, so we can't plug it back in there. So I am going to do 5 and then times my x value, which is the negative 17 plus 7y over 2 plus 8y equals negative 17. Okay. And I will distribute my 5. All right. We could treat this like 5 over 1. Okay. So I'm going to distribute my 5 to the negative 17, and I will get negative 85 distribute to the 7y, and I will get a positive 37y. That's still over 2, right? Because when you multiply fractions, you multiply the numerators together and the denominators together. Plus 8y equals negative 17. Okay, so that's where we are. Again, still looks ugly. Don't be afraid of something looking ugly. It doesn't mean it's more complicated. Just means you might have to clean up a little bit more. Okay, so I'm going to duplicate that and I'm going to come up here so I can keep solving. Move it 1 down so we have a place for my answer. All right. The first thing I'm going to do, just because I know it bothers a lot of people, is I'm going to go ahead and get rid of that fraction. Remember, you can always get rid of fractions by multiplying through by the denominator. My denominators are 2, so I am going to multiply my entire equation through by a 2. If you do it to one side, you have to do it to the other, and that's why I'm doing that. Okay, so when I distribute my 2, I will get the 2 over the 2. That will cancel that out. Okay, so I distribute my 2 just to this first fraction. And then I'm left with negative 85 plus 37y. So I distributed to the first fraction. Then I have to distribute it to the 8y, okay, because I have to distribute to everything. So plus 16y equals, and then I'm going to distribute the 2 also to the negative 17. And I will get negative 34. So see, all of my fractions went away now. Now I'm back to business as usual. So I'm going to combine the 37y and the 16y. So I end up with negative 85 plus 51y equals negative 34. I am going to add 85 to both sides. And I have 51y equals a positive 51. Divide both sides by 51. And my y, put it over here, my y equals 1. So we did all that work and we ended up with a 1, right? So putting my answer up here, we know our y value, it's 1. Now I'm going to solve for the x. Remember, we're going to take this y value and we're going to plug it into either equation, doesn't matter which one, for the y, and solve for the x. Plug it into the top one this time. So I have 5x plus 8y, which is 1, equals negative 17. So I have 5x plus 8 equals negative 17. Subtract 8 from both sides. I will get 5x equals negative 25. Divide both sides by that 5. And my x equals negative 5. Okay. Remember, after that, if you want to, you can always check and plug it in. All right. You can rewind the video and see how that's done if you want to. And those are the methods for substitution, solving systems of linear equations. That's all we've got today. If you need different or a more specific example, leave a comment and let me know. Like, subscribe, and I will see you guys next time in class. Bye.